Algebra Lesson 7-4A. We've been spending a lot of time dealing with solving systems of equations. We have three different methods: graphing, substitution, and combinations. Speaks a little bit more about those on page 418. We're going to use any form of these that we want to solve some story problems. Most people are not real excited about story problems, even though that's the wonderful place where you can actually see where you can apply these concepts in real life type situations. It's not to say that every person is going to use this exact story problem, but the concept could be similar to some other ones that you might face. And it does give an opportunity for you to see where it can be used. So here we have a chemist that needs to make 30 ounces of a 25% saline solution. They're going to do so by mixing a 15% solution with a 40% solution. We've got to figure out how much of each is necessary to make the 30 ounces of 25% solution. So what I tend to do is take this information and make a drawing. That way I can tell what's happening. Now I don't have any idea how many ounces of this container I'm going to have, and I don't have any idea how many ounces of this container I'm going to have. But I do know when I pour them into the final container, it's going to be 30 ounces. So anything that I don't know, I'm going to create variables. This one right here is 15% solution mixed with the 40% solution to make 25% solution. Most of these situations, we still want to write two equations. One involving quantity, the amounts that we have, these ounces, and then another one including the values. Now, the values in this problem are the percent of saline solution. Now if it was exactly 15 ounces of this and exactly 15 ounces of that, then our final product would be an average of these. But as you look at it, 15 only requires 10% more to get to that, and 40 is 15% more. So it seems like it's a little closer to the lower end. So there might be more of this particular product than there is of this to make it dilute a little bit more. One thing you've got to do is convert the percentages into a decimal. So you'll have 15, you'll have 0.40 and 0.25. So we write our equations now. Our first equation is going to involve quantity. All the x ounces plus all the y ounces has to equal the 30 ounces. This next one's tricky because it actually involves the values, which are our decimal versions of the percentages. 0.15x plus 0.40y is equal to, and you don't want to forget the 25% times 30. Got to be fair. Think about it. This side has got the percent as a decimal times the ounces, percent as a decimal times the ounces, percent as a decimal times the ounces. Now you can actually simplify 0.25 times 30 so that you have 0.15x plus 0.40y equals 7.5. A quarter of 30 is 7.5. Now, maybe you don't want to deal with these decimals. So maybe you decide to multiply everything by 100. And that's fine. You can do that. You now have 15x plus 40y equals 750. And the reason? Because each of these moves two places to the right. Alright, now this one I'm going to use combinations with, and I'm looking at the coefficients. These have coefficients of 1. They are not opposites of 15 or 40. But I can multiply everything up here by negative 15, and then I'll have a matching coefficient with the x's. Negative 15x plus negative 15y equals, and you got to be tricky here, 3 times 15 is 45, so 30 times 15 is 450, but it's negative, so negative 450. So we take this equation and we clone it so we can bring it down here. So all of this was brought down here for linear combinations. So we go to add them now. 15x and negative 15x cancel each other out. You've got 25 more positive y's. And when you look at 750 and negative 450, you get 300. All that's left is to divide by 25. And we end up with y is equal to, now 25 goes into 100 4 times, and there's 3 hundreds, so that means there's going to be 3 fours, which is 12. There is 12 ounces of the Y brand, of the Y product. So if there's 12 ounces here, the only thing you can add to 12 to make 30 would be 18. So 18 ounces of this. Now we mentioned that we thought it would be a little closer to having more ounces in this product because there's only 10% to the average rather than 15% away. So it's a little bit more of this product, which 18 is slightly more than 12 in terms of ounces. So that's an example where you can use linear combinations and solve. All right, another example, 2 online music companies. Company A charges $12 per month. That's no matter how much you do online, and $2 per hour that you're online. Now company B charges a lot more per month, but less per hour that you're on. So what you have to think about is, some people just don't even pay. They're just like, oh, I'll just pay whatever. Well, you might not spend your time on the computer as much, and so one might be cheaper than another for what your purposes are. At the same time, maybe you're on a lot, and so one is a better deal. If we make equations for these, we've got to think about the fact that our B value, our starting amount, no matter what, is $12 per month. And the $2 per hour is our rate of change. So for company A, we could say y equals 2x plus 12. Because no matter what, we're going to spend $12, and then it goes up from there, $2 every hour. Company B, somewhat similar, except this has a much cheaper rate per hour, but a lot higher starting amount. Since both of these are in the form y equals mx plus b, and we're using it to make a decision as to where a break-even point is, a graph could be helpful. So I went ahead and I made the graph. And you can see across the bottom, we've got hours, and we have our cost. So here's our first equation, which is that y equals 2x plus 12 is right here. And then we have y equals 0.5x plus 27. Its cost starts a lot higher. This one starts a lot lower. If you're not planning on watching or listening to music online very much, the first 10 hours, it's cheaper to be in this company because this one's more expensive. But once you get to 10 hours, it really doesn't matter which company you choose. It's exactly the same cost. 2 times 10 is 20, plus 12 is 32. Half of 10 is 5, 5 plus 27 is 32. So 10 hours online is going to be the same for either company. But after 10 hours, this company becomes more expensive because they're paying more per hour. Whereas this company is cheaper because it's only 50 cents per hour. So you need to make a decision. Is it something you're going to do a lot? Then you probably want to go with the more expensive company to start with. All right? So there's an example where we could use some graphs. One more example, another mixture problem. Similar to the mixture problem we used with the saline solution. It says we have a mix of $4 per pound granola and $2 per pound of raisin to make 25-pound bag of the mixture. How many pounds of raisins are needed if I want to make a mixture that costs $80? Well, let's go back to the same concept. These are the bags. We know we have granola and we have raisins. If we take all the pounds of granola and add it to all the pounds of the raisins to make the mixture, it's supposed to be 25 pounds. Okay? We know the costs. The granola is $4 per pound. The raisins are $2 per pound. And we know when we're done, we'd like it to make a total mixture that costs $80. Not $80 per pound, just a total of $80. Remember, our two equations generally involve quantity and value. Quantity-wise, we could say all the granola plus all the raisins has to equal 25 pounds. Then we involve the costs. So we could say $4 times all the pounds of granola plus $2 times all the pounds of the raisins has to equal a total cost of $80. It's not $80 per pound, just a total of $80. So again, if it were me, I would probably use linear combinations, and maybe multiply everything by -2. That way the r's will match up. So we get -2g plus -2r equals -50. And this we can clone and bring over here. And take all of this and bring it over there. So we can add it together with linear combinations. 4g plus -2g is 2g. 2r and -2r cancel out. 80 and -50 equals 30. So when you solve, you divide by 2, and you now know how many pounds of granola that you have. You have 15 pounds. That makes it pretty easy because if you have 15 pounds of granola, 15 plus r has to equal 25. That means r has to be 10 pounds. And if you think about the cost, it's not very much average here. It's all the way out to 80. So yeah, we would probably need to have a lot more pounds of the granola to jack the price up to 80. So there's 3 different situations involving story problems, depending on what you have as information. These are the trickiest ones. That's why I have this example for you. You just want to do the best you can, but always start with these 2 concepts, quantity and value, to write your 2 equations and then solve from there.